Today we've got a great reading for you on basic reasoning. Idea is really how do we scale chain of thought? With me today, I have Parth. Before I let him introduce himself, I'm just going to do a quick intro on my side. I'm Sally Ann. I'm one of the product managers here at Rise. Spent a lot of time working on our own AI agent Copilot, seeing how we can improve it and improve people's workflows in our platform, as well as managing a few other areas of our product and spending a lot of time with our customers to see what they're working on. Parth, you want to give a little bit of an intro?
Yeah, of course. Hey everyone, my name's Parth, and I'm a software engineer here at Rise. I work on a lot of our backend services, especially surrounding our database and database querying, and making sure that whatever fuels our pages in terms of data querying is as fast as it can be.
So cool. Well, let's dive into it. First, before we get into the paper, I got some few housekeeping items. So the first is around our conference observe. We are almost a month out here. You don't want to miss this one. Our early bird sale does end on the 31st, so you're going to want to grab your tickets before the price goes up. You can see there we've a lot of good sponsors and presentations. So folks from OpenAI, NVIDIA, Priceline, Crew, and many more are going to be there. So I'll be there. I think Parth will be there too. So definitely don't want to miss out on that one. Awesome. So AI industry updates. I'm going to keep it short and simple this week because I feel like the main headline that I saw was the fact that OpenAI has agreed to buy Windsurf for $3 billion. That is quite a nice payday for the folks at Windsurf. If you're not familiar, Windsurf is like a cursor competitor in AI IDE. So super excited to kind of see what OpenAI plans to do with it. But that's, I think, one of the main updates in the last few weeks here. All right, let's dive into the paper. So again, today we're going to be covering scalable chain of thought versus via elastic reasoning. So really interesting concept here. Parth, you want to take it away?
Yeah, sure. So, when it comes to why we care about inference cost, the so or Sally, do you mind taking this slide and then
Yeah,
I
no
can I
worries.
can take the following. Yeah, okay. Thank you.
Totally. Yeah. So I think the main thing to understand here is we've had these recent developments of models that are reasoning models. So like the O1, the R1, where we have super strong capabilities when we use reasoning. But we have this a concept of test time compute where this is the compute used to generate a response. So this includes the reasoning decoding. And so what this has led to is this concept of test time scaling. It's like, how do we scale this? Basically letting the model think longer and reason deeper, but this will yield better answers and has some trade-offs. So each of those additional decoding steps, that means longer latency for users. When you have a user-facing application, you really don't want them having to wait, a few minutes for a response. Most of them are going to close out of that application. And there's also a higher GPU cost for the provider as well. So this is very similar to a paper we did previously. This is what this paper is aiming to explore. It's like, how do we handle this test time scaling in a way that scales is really what we're going to be diving into today.
Sure. So the big idea here is that you you often receive a total token budget that you want to use to kind of break down both the reasoning and solution steps. And usually it's done all in one go. There's not typically a separation between these reasoning or thinking and solution steps. But the big idea behind this paper is that they forcibly provide budgets for both of these steps. And the reason why is because um, you want to make sure that you get through both of these steps, even if there are leftover tokens in either budget. It's better that you ensure that even if you have tokens left over, you 100% are guaranteed to have both. And this has been proved. Both of these, including both of these steps, has been proved to drastically increase your accuracy. Um,
Yeah.
and
Before we
yeah,
dive into that, I just think it's interesting of like, let's talk a little bit about like why bother splitting output into like thinking and solution tokens at all. You want to touch on what your thoughts on that?
Yeah. So, like as I mentioned, the having both of these steps is certainly leading. um, is leading performance in comparison to just having like one of the two steps. Um, and kind of it's kind of like having the model work its way through different options before it kind of gives you its final solution. You can almost think of it as the thinking. So typically the thinking budget is larger than the solution budget. And what's going on here is that the solution budget often tends to be a kind of um, a nuanced summary of what's going on in the thinking stage of the of this technique. So kind of giving the model a chance to provide its own context or pathways that it could take typically improves its performance. Is that kind of answer your question? Do you have anything more to?
Yeah, no, I think that makes a lot of sense. I kind of wanted to set the scene for the audience here of like
Mhm.
why we would even bother doing this. And I
Makes
think
sense.
to summarize is also is a key point that the paper tries to make is um, it's kind of trying to guarantee that the answer is also going to always fit, even when like the reasoning kind of overruns. And I think we'll talk a little bit more about that later. I think
Mhm.
also analogy that I saw a few times when people were talking about this paper is like, um, it again tries to almost mimic the way that like human mind works, or if you have this kind of draft versus final concept in like human workflows, it does kind of mirror that a little bit, but I also think that that's misleading because it was almost be as if like you were thinking through a problem and then somebody like abruptly told you, hey, stop, give me the solution, summarize what you just thought about. So it is kind of interesting to think about. I think folks try to force these human kind of analogies when they don't necessarily, match. But
And
yeah.
I was gonna say maybe that's like if you're thinking about this is a bit tangential, but like interpretability and what these models are really trying to do, it could I mean it could improve their uh, or at least it can help people feel like they have more of a view into this black box of a model. I mean, most people that use these models treat them like black boxes, but if they have some kind of view into the the thinking or reasoning portion of this process, like you said, it could make it almost feel more human, and it's just more comfort, in my opinion, too.
Yeah, no, I think that's a really good point there. There's definitely, we see the reasoning being used to understand, or chain of thought in general being used to understand like what the steps are. So I think that's a really valid point.
Okay.
Um, let's talk about why this is important.
Yeah. Right. So in the real world, there's always budgets that engineers need to take into account, right? And no matter what, or like w no matter what this budget is, and you still need to be able to do the best with what you have. And in this case, that includes a complete solution having both of these phases, right? Like I was saying earlier, this technique um, allows both the reasoning and the solution part to always exist. And even if one of these phases has a really extreme token budget, it's still better in the end than having not like than not having one of these two phases at all, unless it kind of follows the structure of one of these early ideas where what they do is constrain the thinking process to a predetermined number of tokens. For example, the example they give in the paper is like as you can see, the model in the thinking portion would say, "Oh, I'm currently trying to figure out how I would," and then it just gets cut off. This can be detrimental to a model, and this is what you don't want to do, and that's why they introduced oops, sorry about that. This is why they introduced a kind of budget constrained rollout or a fine tuning. And what this does is it prevents these kind of abrupt cutoffs from happening by training these models with a variable number of budgeted tokens. Really allowing the model to take these constraints into consideration beforehand, before it produces these kind of these thinking slash reasoning texts. And you can kind of think about this, you can kind of interpret this as a model receives a very small token budget. What does it do? it abridges this chain of thought so that, what you see here doesn't happen, so that it doesn't get suddenly cut off. And in the solution, if it receives an extremely low token budget, maybe it'll use less fluff words. So this is done by a reinforcement learning algorithm called GRPO, and it really helps the model almost understand what it's working with and make sure that it gets as much as it can out of what it can work with. Do you have anything? Do you have anything to add to that, Sally?
No, I think just to maybe summarize the two kind of pieces of this, like the core proposal of elastic reasoning. It's like there's a separate budgeting at inference, which Parth covered first, and that's when we're gonna like hard split every answer into thinking and solution. If basically thinking ever overruns it, it is forcibly injected and switched to the solution side. So the idea is always to have this complete answer segment. And
Mhm.
then kind of then there's this like budget constrained fine tuning where we're basically giving a fixed pair of thinking and solution, and then the model is expecting this kind of truncated reasoning and learns to prioritize those high value thoughts early on versus like going through this long reasoning to get there. So that's kind of the summary of these two pieces of, and that is their proposal there. Cool results. So they used a few different training sets here, and then as we're looking at some of the benchmarks that they used as well, try to kind of distill out the key points that they saw through their results. So one, accuracy holds under tight budgets. So you can kind of see that in these two graphs here of we have pass at one, which is kind of a performance metric here. That red star line is the model that they've kind of fine-tuned for the two tasks there. So you have E1 math and the live code bench equivalent. And as you can see, even at those like lower, that like bottom left corner, those lower tokens amounts that were used, we're still seeing performance that beats any of the other options here. So accuracy definitely is going to hold under tight budgets. The other thing that they saw is there were big drops in inference costs. It was about like 32% on the AIME and 37% on Copen. So those are pretty substantial savings in inference cost. I'm sure anybody here who is, dealing with cost on the day-to-day understands like if you could go to one of your stakeholders and say you dropped your cost by 30%, they would be elated. Um, the last point here is it requires about 75% less reinforcement learning steps compared to previous methods. So in that kind of second half, that budget constrained rollout training, I think it took like 200 steps. And some of the other methods, we didn't talk too much about kind of previous methods that exist, but there's this one where there's this forced truncating of reasoning happening. And I believe that when they were doing the reinforcement learning there, it took like 800 reinforcement learning steps. So you can see also in the effort needed to actually do the training, it is, saving a lot. So I think those would be some of the key takeaways here. As you kind of squeeze budget, another thing to mention is like you're not going to see a real drastic drop. So there is a little bit of flexibility with this as well, which I think is kind of an important point. Those are key kind of takeaways. We figured for the last little bit here, I'd love to kind of answer questions, but I think there's a few things, Parth, that might be worth kind of picking your brain on. Of hallucinations, I think are something that everybody is worried about, or it's constantly something that we talk to customers about. Do you think that hard cutting kind of this like thinking stream has a risk for hallucinated answers?
Um, I don't think the risk of hallucination drops, but
Mm.
the good thing about this actually is I think at least if you get a hallucination in the solutions portion, you can
Mhm.
see the kind of steps that the model is taking towards this hallucination, unlike unlike just receiving a solution straight off the bat, like not from a chain of thought. So I think if you're trying to interpret what's going on, where you're going wrong, um, I think I think this might I don't think this will necessarily cause or like prevent neither cause or prevent hallucinations, but what it can do is just almost help you debug. Like it almost help you
Yeah.
debug why it's leading to that in the first place, and what you need to change in your prompting, stuff like that.
I agree. I think it's a great, like evals would still be super relevant here of having
Yeah.
that. You might log some additional information, perhaps,
Mhm.
of like what those kind of ceilings are.
Mhm.
And I totally agree. Is like you can use that information to start tuning some knobs of like maybe we would try with like a larger budget, or do we try to escalate to maybe like a bigger model if we're sensing some hallucinations happening. So I totally agree. I don't think anything here is going to really like adjust hallucination. I think there's potential that if things are abruptly truncated and we don't have complete thinking and maybe our ceiling for thinking is way too low, there's definitely risk because the LLM essentially has incomplete information. But I think again, if you are evaluating it and logging the right information, you can just use this to adjust how you're setting things up.
Yeah, I mean, if we're talking evals,
Yeah.
I'm just curious. Do you what's the kind of do you know what the latest is on kind of evals of specifically models that use chain of thought and how that's different between kind of the simpler models that are just used to get kind of solutions right off the bat?
Yeah, I think they're very, very similar. I think that the differences is you're probably going to want to pay attention to that reasoning a little bit more. It's just like an additional field that you're going to use when you're evaluating. I haven't
Mhm.
really seen anything like too specific. I just think almost that they become more important to evaluate is understanding like is it over reasoning? Do I even need reasoning? Because that's the other thing. It's like
Yeah.
these models are more expensive. And that's something that I feel like I have conversations around a lot is like you don't just because O1 R1 is like super powerful,
Mhm.
you don't always need it for every task. Sometimes
Yeah.
the reasoning can be at a disadvantage for a few reasons. One, you just don't get the right answer because it's kind of over indexing on the wrong things. The other thing is like there's a lot of cost and latency associated with that.
Exactly. Yeah. And I think this overkill that you're talking about in terms of model use is pretty common. But at the very least, if people are trying to kind of use these reasoning models to do not super complicated things,
Mhm.
I think at least now, like if you're using this technique, you could at least adjust the token budget to be like lower. You don't have to like if people aren't willing to take the step down into use a simpler model as compared to reasoning model, they could always adjust the token budget now.
Totally. It's interesting, kind of another thought I had, somewhat related, is just like, how do you think we could evolve these budget caps for like, multi-tool agents? I feel like the ZR the agents, everybody's thinking about agents. Doesn't touch too much on this, but um, I'm wondering how like maybe what other knobs might exist or how we might stop like runaway tool loops even too.
That's actually really interesting. I mean, talking about these kind of budget separations in terms of multi-tool agents. Okay. So, man, that's a whole other paper.
I know it is. I mean, I think the low-hanging fruit was like imagine there's separate ceilings for like
Yeah.
reasoning tokens, and now there's like this tool call token
Yeah.
kind of area too. Like that's how I think it would work, and I also think there would definitely be kind of knobs around which maybe models are used for which either because just with all that complexity of you want to make sure that the right model is being used for the right task and um that's at least how I'm thinking about it. It's just like additional knobs, additional kind of budgets for different things.
Yeah. I mean, I'm sure like because in this paper you had that where is it? You had that rollout that was used to kind of I guess teach the model not only there's a rollout to teach the model how to work with kind of these budget constraints. But if you could do that with you can obviously do this with tools too, or like LLMs that employ tools as well. Kind of.
Mhm.
So I think this is I think the training time would be really high for these agents that kind of that use tools, and you try to figure out the kind of optimal these optimal budget constraints. But this is definitely doable, and I think. when you if you're talking overkill, like people are going to use models that are a lot more complicated than they need for certain agents. So I think, man, if Arise ever starts doing research, we need to hop on that first. That's a yeah, that's a good great idea. Yeah.
Awesome.
Anything else you had on your mind?
No, I think that that covered it. I think something that's worth talking about. I think a lot of folks that join us here today are kind of trying to understand, like, so what? Like, why does this matter to me? Type of thing. And I think it'd be worth kind of discussing, what maybe real world settings this actually makes sense. Where we talked about how reasoning models, like, not always doesn't always make sense for the task. Well, what about this like elastic reasoning? When should teams maybe think about investing in something like this?
Hmm.
I think for me, like the way that I think about it is if you have anything that's like token sensitive, where you really need to be thinking about the tokens or even like latency critical user flows. So you have a chatbot where you need the latency to be like really less than, 1 second. So it's instant. Um, those are two places I think it obviously makes sense. And then taking from the paper of the type of tasks they tested on, anything that has like those structured reasoning, like math or code. Even I think data analysis would be really interesting to explore with this.
Yeah, yeah.
Yeah, I think
Data
about.
data analysis, especially like with a lot of these tools, like these data analysis tools, you want to create experiences that feel like magic.
Hmm.
But that is really difficult to do when you're working with these really high level reasoning models. The same thing with the chatbot. If you want to be able to handle the complexity that reasoning models do, but again, you want to you want to provide these like seamless um, experiences for customers. I think th this would be a great use case. This would be a great use case, especially because uh, like people kind of underestimate how important uh, I guess latency really is when it comes to customer facing applications. You know,
100%. Yeah, it's like
it,
one of the
it,
biggest things from like a product perspective that we think about is like I said at the very beginning, if you have this really powerful reasoning model that produces great answers, but it takes it 3 minutes to do it, no user is sitting around for those 3 minutes to wait for that out. It doesn't matter how good it is. So there is this kind of balance that we have to strike of really good answers, really powerful models, but user experience. So that latency of like how quick can we get it, how concise. It also sometimes if you give it like multiple paragraphs of information to read, a user's also not going to read that. So I think that's really valid. And I think in terms of like where this doesn't fit is anywhere where the truncation will potentially cause worse results or potentially, that information is actually critical for like auditing purposes. I think those are the two areas where I would say that like this definitely doesn't make any sense.
yeah, like I mean, we're talking like applications in research
Mhm.
or really any kind of reading or writing. I
100%.
think you're totally right about that. But I think the steps that so I think it's interesting because obviously research we're talking about like you know interpreting like lots and lots and lots of text and providing genuinely insightful responses. That may not be the place to include a technique like this, but
Mhm.
man, like the vast majority of where AI is being used right now is in a product. I mean,
Yep.
correct me if I'm wrong,
Yep.
but like uh if that's the case, then I'm glad I think this is a great step in the right direction when it comes to making sure that we're not, well, like again, this is a bit of a tangent, but a single call to ChatGPT is like it costs like 10 times the energy of a Google search. So
Yeah.
it's like the last thing you want to do, even in terms of like an environmental perspective, cost perspective, is just like use these overpowered models for things that you don't need. And
Yeah.
Um, I'm really happy. Like this is a step in the right direction, and yeah, like
I
especially if you're
totally
thinking about like environmental costs and stuff like that.
Yeah, I totally agree. We did a paper reading like 2 weeks ago on again, it was aiming to kind of solve a similar issue of like the timescale compute. And I do think the environmental impact is something that we do have to solve. Like it is really inefficient right now from an environmental perspective to do anything with these models. So like the more that we can do around there, I think it ultimately will propel the industry forward and make sure we're doing it in a sustainable way. So I agree with that.
See,
Last
the
4 minutes here. Oh, you had something else to add?
no, I was just gonna sorry to cut you off, but I was gonna say I mean, if you're thinking about environmental costs and stuff like that, the there's always a tendency for, oh, we're reducing the cost by 50%. Just make another call, you know?
Yeah,
So it's like is is an engineer more likely to kind of run away with with the benefits that they reap from creating a more efficient model and kind of just s- um accept that I guess the accuracy is the same, but they have less of a cost, or are they just likely to make another call?
right.
Anyway, that's what I wanted to leave you
Yeah,
with.
it is
It's
a good thing to
we
think of.
always we always want more,
Yes,
that's
of
it's an
course, pushing
attitude
those
thing.
boundaries.
Sorry to
Well,
cut you off.
no, that's perfect. I mean, I think that's a good segue. Of like my last question here was going to be like, all right, future work. What are you excited to see come from this? What do you think the future of this is for like even the next wave of LLM products? What are your thoughts on that?
I think that the next wave of LLM products actually I think the next wave is more likely to focus on um, being being as lightweight as possible. I mean, this is also another use case of an LLM, but like constrained to, a singular device, like a cell phone, Like for example, things like Apple Intelligence or things like these are really trying to focus on providing these, local, like lightweight reasoning models. And I think that you know, steps in the right direction, like the paper that we focused on today, are, a great step towards what's next in terms of these kind of smaller, lightweight models. And I think that we haven't I mean, a model like this, you can almost think of it like an oracle. It's almost all knowing, but you don't need all knowing in 95% of these applications. You
Yeah,
need something that can do a couple things really well. And I think the next step is, training training on these very specific like user applications. Like for example, chatbots. Um, a lot of these models used for chatbots can do a lot more, can do a lot more than they're prompted to do. For example, like chatbots, in the prompt, it's if a user goes off topic, say, "Oh, I'm sorry, I can't help you," but it's because we're prompting it to do that it won't do it. But it has the capability, meaning we're using a chainsaw to mow grass here. Like I think these lightweight, more, um, practical, focused models are what's next, and this is a good step in that direction.
100%. I think there's a lot of exciting stuff ahead for us, but we are at time. This was a super good one to dive into. Thanks everybody for joining, and thanks Parth for kind of sharing your thoughts and joining today. Thanks
Oh, my
everyone.
pleasure.
Bye. Y'all.